In this video, we're going to be looking at how to add and subtract rational expressions. Now, in the last one, you did polynomials. The only difference is going to be that here you're working with what appears to be fractions. It's not really the same as back into 1/2, 3/4, 1/4 type fractions. These are going to be algebraic fractions. So when you see that word, the word rational, just think that you're going to have something on top of something else. You're going to have a numerator. Underneath of that, you're going to have a denominator. Now, if this section kind of gives you a little bit of a headache, that's normal. But what I want you to understand is that all the rules apply that you've learned for years, and that you need to come up with a common denominator. Now, number one, you look at these, and the common denominator already exists. It already happened for you. So for both of them, you have 8v to the second, u to the second. Also, you can rewrite this to where it doesn't look quite as scary. And that's what your goal is going to be on every problem, is to make it less and less scary in each step. That's what it means to simplify. You get it shorter and shorter. If you have a common denominator, one of these can go away. Let me explain that. I'm going to rewrite this in a way that I only need to write, and I'm going to switch u and v around because they should be in alphabetical order. They're not on here. I'm going to rewrite this in a way that doesn't look as bad. It's going to combine what you just did with what we're doing now. The one thing you've got to understand, though, is that you have parentheses around your numerators. You actually have parentheses around your denominators too, but that's not always that important. But those are built in every time you see a fraction. If you have a common denominator, the only thing you need to worry about is the top half, but the bottom half needs to be there. And that's as you get started. So the top is u plus 5v minus u minus 6v. You put a tail on that, so you can tell the u's from the v's. You just did this as adding and subtracting polynomials. It's where you distributed a -1 across both terms in the parentheses following a negative sign. So I'm going to rewrite this in the numerator is u plus 5v minus u plus 6v. Make sure you understand where that plus sign comes from distributing a negative onto another negative. So here's my step. Now, if you look at this real close, you have, in the way of your like terms, you have u minus u. Well, those cancel out. They cancel each other out. So 5v plus 6v, that's combinable to 11v. Under that, the denominator remains. Now, this isn't fully simplified because I have a v here and I have a v term down here as well. So go back to simplifying algebraic expressions, and you know that this means there's two v's. Up here there's just one. So that cancels with that one. So your answer becomes, and I've run out of the room, 11 over 8 u squared v. So that's a fully simplified answer for adding and subtracting rational expressions. Now, this is your last stepping stone until you move into this, going from expressions into equations, which actually becomes much easier. I'd say this is a hurdle you're going to have to get across as you come up with how to answer questions. I'm going to do, let's see, looks like 7 problems, so you'll see this over and over again and have a chance to ask questions in class also. All right, number 3. We haven't really gotten any different in number 3. You still have a negative sign here in the middle, but you have a common denominator already. You have 6a to the third power for both. So I'm going to rewrite my numerator, a plus 2b minus 5a minus 4b. Again, make sure you understand where that minus 4b comes from, or this is going to be confusing every time you do a problem, and several times as you do it. That negative sign distributes across invisible parentheses. Now, what goes underneath that? That's just your common denominator. You don't do any math in the denominator. This sign, the negative sign, only affects the numerator from the way you're doing your work. So 6a to the third, once at the bottom, and you're done. Now, what combines? I can combine a with negative 5a. A comes first in the alphabet, so we'll do it first. So that's negative 4a. And then 2b minus 4b is negative 2b. And I'm going to put that over 6a to the third. Here's the trick. I'm not done yet. I have a 4, a 2, and a 6. Technically a negative 4 and a negative 2. But what I'm looking for when I mark those, I'm looking for a common denominator. No, take that back. I'm looking for a common factor. We go down and start a new row. Right up here, I can do something with this. I'm going to take a negative 2 out. Now, as you gain experience, you'll understand why I took a negative out. It's better to have a lead-off positive term in parentheses, but that's not a big deal right now. If I take a negative 2 out of my numerator, I'm going to be left with 2a plus b on top. Underneath of that, I would have 6a to the third power. What that lets me do is simplify negative 2/6 down to a negative 1/3. So 2 divided by 2 is 1. 6 divided by 2 is 3. So my answer is negative 1, which you just put a negative sign, 2a plus b, over 3a to the third power. That's as far as you can take that. Now that is the same as if you had negative 2a minus b over 3a to the third. I've worked with a lot of math teachers that prefer one over the other, and some don't care. They're mathematically the same, so I fall into the don't care category. I'm not going to count you wrong if you're mathematically correct and both are fully simplified. So either of those answers would work fine for me. Alright, problem 5, we're just stepping up the complexity of it a little bit more. I want you to always be thinking every time you do anything involving polynomials. We'll factor first thing. I'll say it 1,000 times. Remember, my goal is a common denominator, which I have. I have a common denominator. But I do want you to factor things and be thinking about factoring anyway. Even if you don't actually do it, let's make a thought bubble. So I want you to think about factoring first. The main goal is I want to copy, or I want to add those, meaning I have 4a plus a, which is 5a, and I have a negative 5 plus a negative 1, which is negative 6, and under that I have a common denominator of 6a to the second plus 30a. Now I skipped a step that I did with you back in the other problems. Like on the previous problem, I rewrote this entire thing out, and then I simplified it. It might have seemed redundant if you understood what was happening. Moving to problem 5, I didn't write that step. If you can follow where I got 5a minus 6, you're in a good place. If you can't, you need to revisit problems 1 through 4. But what I did is I combined my like terms. Since this was a plus, I didn't have anything to worry about. 4a plus an a is 5a. Negative 5 plus a negative 1 is a negative 6. Now where's factor first come in? I have a couple of things in common between my terms and my denominator. I have factors of 6, and then I also have an a in each term. I don't want something that's the same in both terms, so I know I need a factor. I'm going to factor out a 6a, which leaves me with a plus 5. There are many times when you will find something in the numerator that will cancel with something in the denominator. Don't force the issue, though. In this case, 5a minus 6 and 6a, a plus 5, there's nothing you can cancel. So I'm done. But without factoring this denominator, I would not have known that I wasn't done yet. So you do need to take that into fully factored form, like I showed here at the answer. If you had 5a minus 6 over 6a squared plus 30a, you would lose points for that answer. You need to take it a step further and make sure that you are doing your factor step. All right, number 4, no, the fourth problem, number 9, that I'm showing you, and there'll be 3 more after this one, deals with denominators that aren't the same. The previous one, they're the same. The one before that, they're the same already. So now you're stepping up the complexity just a little bit. But I'm still going to start out with factor first. Also, I'm going to change where I have this. I'm going to move this on down because I want to work out from the middle. All right, 20x plus 16 has a common factor of a 4. If I pull a 4 out, I'm left with 5x plus 4. I have a 2x over here. So I want to ask myself, what's missing? And I want to look specifically at my denominators when I ask that question. I want the 2x, and I want the 4 times the 5x plus 4. Remember, my goal is that I want common denominators. So essentially what I'm after is a common denominator that will include 4 and x and a 5x plus 4. That's my common denominator. I want it to include everything that I have. 2 can go into 4, so I've got that covered. So I need all those other little pieces as well. Here's how I do it. If I want to turn this 2 into the 4 I'm looking for, I need to multiply it by 2. That would turn my denominator into 4x. The only way to keep this even, though, is to multiply this by 2. You know, now that I look at something, I'm going to take this x out of there. The reason I can do that is an x divided by an x cancels in my problem. Essentially, I was simplifying that fraction, which makes my life a lot easier. All right, now I have 4 as a denominator for both, but I also need this 5x plus 4 in there. I can't add and subtract. All I can do is multiply and divide. So I'm going to multiply this fraction by 5x plus 4 on the top and the bottom. And so that's where I'm at. Now I want to take this big mess. We'll cut it off right here. And let's, oops, I completely missed what I was trying to do there. Take that, I'm going to group these. Let's copy those. I need a new page. Alright, so here I am. Just needed a little extra room. Alright, so what I'm looking at, I'm focused on this problem up here. The first part of that problem is going to be 2 times 7. If you can read that in there, here's my 2 times 7, which is 14 times 5x plus 4 minus x minus 2 over. Now, all of this math right here was just done to get it equaled to this. So this is 4 times 5x plus 4. That's my common denominator. Now you can imagine what I'm going to have to do right here is to simplify all that down. Group those again so I can move them down. Alright, so 14 times 5. That's 50 plus 20, which is 70x, plus 14 times 4, which is 40 plus 16, which is 56. Distribute your negative, and now I need to combine my like terms. What's 70 minus 1? 69x. 56 plus 2 is 58. And that is all going to be over 4 times 5x plus 4. Now, there are no common denominators or common factors of 69 and 58. You can spend a lot of time looking through that, but you're actually finished at that point. So that problem was a little more complicated. You had to get your denominators the same. You had to distribute on top to account for what you did to make that fraction equal, and then still combine like terms and possibly even factor after that. So it's more complicated. It's not necessarily harder. It's just easier to get lost in. Okay, the third to the last one is going to be way easier to model than the last the last one we just got finished with. because I have less going on. So you won't get lost in the translation here. My common denominator is going to be 8 times 5e minus 2. I can turn both of those fractions into that. So that's going to be what's underneath. To be able to combine my two numerators together, the fraction on the right needs to be multiplied by an 8 on the top and bottom. The fraction on the left needs to be multiplied by a 5b minus 2 on the top and on the bottom. You notice that on both of these, 5e minus 2 times 8, let me highlight those, and 5e minus 2 times 8, they're the same. That's my common denominator. I can leave that alone. So going back to my numerator, I've got to do 7v times 5v minus 2 minus 8 times 8v minus 4. And that's the problem that I wrote up here on top. So 7v times 5v is 35v to the second. 7v times negative 2 is negative 14v. And that's going to be minus 64v. And negative 8 times negative 4 is plus 32. So let's combine like terms. Let's take this down to the next step. I have 35v to the second minus 78v plus 32. All over 8 times 5v minus 2. Alright, if you made it that far and you followed that, you're in good shape. Now is the time where you have to see if you can factor this trinomial at the top to possibly have a 5v minus 2 in it, because there may be something that that we can go further with. And these are big numbers, and I don't see an easy way of reducing them. 35. No, I don't see a way of reducing it. So let's run a factor tree over here. The things I've got to factor are my leading term, which is 35, and my end term, which is 32. In the world of trinomials, that's A and C. So 35 is 1 times 35, and it's 5 times 7. 32 has a bunch more, though. Alright, if I'm trying to get 5e minus 2 to cancel, if that's one of my goals, I'm going to try to use a little bit of logic to figure that out. It would have to be those two pairs if this is going to work. Alright, so how do I get a negative 78? Can I get a negative 78 out of those two terms? And that's going to be my main thing. So let's run a hypothetical situation here. If one of these is 5v minus 2, what would the other one have to be? Well, the only way to get 35v to the second, if one is 5v, is the other one would have to be 7v. So that's those two terms. Well, if one of these was 2, to get me to 5e minus 2, the other one would have to be 16. So let's just play with this, see if it works. 5 times 16 is 80. 7v times 2, that's 14. Well, you can't combine 80 and 14 into anything that's going to get you 78 in the middle. So I am just going to go out on a limb and say that I'm done in that step. I don't need to worry about factoring further. And if you figure out a way to factor that that's different, I won't spend time in the video. But if you find a way to do that, let me know in class. All right, number 12. Common denominator. I want this to be a quick process. I'm just going to model it at how I do this. I know my common denominator is going to be n plus 7 times n minus 2. I also know what's missing. Remember that question, what's missing? On top, on the 4, is an n minus 2. On the 7, what's missing is an n plus 7. Now, I'm not going to write that again down on each one of these. I would put an n minus 2 here and an n plus 7 there, but I think it'll just confuse you at this point. So what I'm going to write is 4n minus 8. That's this. Then I'm going to put minus 7n minus 49. That's this negative 7 being distributed out to n plus 7 over these. Do not multiply out the denominator. It won't get you anywhere. 4n minus 7n is negative 3n. Negative 8 minus 49 is negative 57. Rewrite again on the denominator. Now, do we have a common factor in 3 and 57? And we do, because 57 is 3 away from 60, which is an obvious multiple of 3. I'm going to pull out a negative 3, which leaves me n plus 19. But that really didn't get me anywhere because nothing canceled. So if you didn't do that step, it's not really a big deal. But I want you to see that process of what's missing, helping you determine what to multiply by. All right, last one. I'm going to factor first. I want to pull out a 3n, and that's going to be n plus 8 on the bottom. Okay, a little bit trickier in your common denominator. It's all dependent on your skill level of what you've done before. But I'm going to want it to include 2n and 3n in the common denominator, so that's 6n. So I already know I'm going to have to multiply this by 2. I'm going to have to multiply that by 3, just with that first portion. Also, I need an n plus 8 in my denominator. So I need to put an n plus 8. Not there. That's not right. I need to put the n plus 8 here. It's not missing here. It is on this one already. I need to put it over here. All right, so on top, I have 2 times 7, which is 14, minus 7 times 3 is 21. And then 21 times 8 is 168. Let's combine that together. 14 minus 168 is probably going to be the hardest part of this whole problem. So that's going to be 154. And then you have to copy your denominator each time, and that's kind of annoying. All right, so 21 and 154, do you have a common factor there? I think 154 can be divided by 3. No, I don't think it can. Let's see if it can be divided by 7. Sure can. So 7 times 22. And I know 7 will go into 21 also. So I can pull out a negative 7 and get 3n plus 22 over 6n times n plus 8. All right, again, that didn't get me anywhere. This looks better. I think you would impress more math teachers by doing this, but it's mathematically the same as this step up here. All right, so it will get more complicated. There are other problems that will throw curveballs at you on that page. But let's work together in class. When you have questions, let me know. And if you have 2 or 3 friends that are working on the same paper, be sure you're getting together in study groups and these things. All right, good luck.